Good morning. So today we'll discuss about S parameters. So the topic of discussion today is S parameters. So S parameters can also be called as scattering parameters. Okay, so we are going to discuss scattering parameters of a microwave network. So this scattering parameter, it is a method of characterizing your circuit performance. So it is a method of characterizing circuit performance. Circuit performance at high frequencies. Okay, so it is a method of characterizing circuit performance at high frequencies. Where? In waveguide. And your S parameters or scattering parameters are related to power waves. Here your S parameter is usually displayed in a matrix. Okay, so it is displayed in a matrix form. So that is why we even call it as scattering matrix. So your scattering matrix is a mathematical construct which quantifies how your RF energy propagates through a multiport network. Okay, so your scattering matrix, it is a mathematical construct which quantifies how your RF energy propagates through a multiport network. Okay, so in S matrix, the number of rows and columns. Okay, so in S matrix, the number of rows and columns is equal to the number of port. Okay, so for an n port, it will have n power 2 parameters. Okay, so it will have n power 2 parameters, each one representing your input and output path. Okay, so for a n port, it contains n power 2 parameters, each one representing input and output path. So for an RF signal instant on one port, some amount of signal or some fraction of signal will get reflected. And so if I say Sij, so this is my parameter. If I represent it in terms of Sij, I is my output port, that is, it is my reflected wave. Okay, and J is my input port, it is representing my incident wave. Right, so if Sij is my parameter, I is my reflected wave and J is my incident wave. So incident wave at my input port and reflected wave is at output port, because for an RF signal incident on one port, some fraction of the signal will be getting reflected. Okay, so if I draw and generalized two port network, say for example I have a two port network, so this is my input port and this is my output port. So this is a two port network, right? So this is my A1, which is incident wave, right? So when I have A1 incident, I may have some reflection at this point, so let us take that as a B1, right? And if this A2 is my incident wave, I may even have some reflection at this port, so let us take it as B2. Okay, so I'll have a characteristic impedance ZL, and here is my input, so I'll have ZS and BS. Okay, so for n port network, I'll have n power 2 parameters, right? So for a 2 port network, I will have 2 power 2 parameters, so I will have 4 parameters. So as it is represented in terms of Sij, so I can say for a 2 port network I have S11, S12, S21 and S22. So 2 power 2. So this is 4 parameters for a 2 port network. Okay, so I will have S11, S12, S21 and S22. So now we have to see individually what is that parameters S11, S12 and all. So we will see that. So suppose I say we have to see what is S11. Okay, so my 2 port network, if I say this is my 2 port network, okay, I have a parameter S11. So this is my port 1 and this is my port 2. So this is my port 2 and this is my port 1. Okay, so here if it is Sij, I is my reflected and J is my incident, right? So here this is my I, and this is my J. So I is my output and J is my input. So J is my incident and I is my reflected, right? So if I say S11, so S11, right? So incident wave is at 1 and reflected wave is also at 1. So I'll have incident wave at A1 and I'll have a reflected wave at B1. Okay, so S11 I can write it like B1 by A1, output by input, right? So S11 refers to the signal reflected at port 1 from signal incident at port 1. Okay, so it refers signal reflected at port 1 from signal incident at port 1, right? So this is your S11. So now let us see for the next parameter. So I will say I will take it S12. Okay, so if this is my 2 port network, so this is my port 2 and this is my port 1. So I say S12, right? So S12, so this 1 is my I and this 2 is my J, and I say J is my input and I is my output. So when I say input, it is incident wave, and I say output, it is reflected wave. So S12 I can write like output by input. So which is output? I, that is 1. So B1 is my output by input. So input is J. So which is J here? 2. So this is A2, right? So S12 I can say, or I can refer like okay. So my incident wave, I'll still clear it. So my incident wave is at A2 and my reflected wave is at B1. Okay, so this is my incident wave and this is my reflected wave. Whereas here in this I had incident wave at port 1, a reflected wave at port 1. Okay, so I can refer S12 as, it refers to the signal reflected at port 1 from signal incident at port 2, right? So same way you can write S21 and S22. So we will see S21. So this is my port 1 and this is my port 2. Okay, so 2 is my I, 1 is my J. So I is my output, J is my input. So when I say input, that is your incident wave. When I say output, that is your reflected wave. Okay, so where do I have incident wave? At 1, right? So incident at A1 and reflected at 2, reflected at B2, right? So this is my reflected and this is my incident. So how can I refer my S21? It refers to the, or how I can write it, S21 equal to B2 output by input, right? So B2 by A1. So it refers to signal reflected at where? Reflected at port 2 for signal incident at port 1, right? Same way I can write for S22. S22. So this is my port 1 and this is my port 2. So this is my I and this is my J. When I say I, this is my output and this is my input. When I say input, that is going to be my incident wave. When I say output, that is going to be my reflected wave. So how can I represent S22? It is output by input. So output is 2, input is also at 2. Okay, so my incident wave is also at 2, my reflected wave is also at 2. So S22 refers a signal reflected at port 2 for a signal incident at port 2. Okay, so now you know how to calculate your S1, S12, S21, S22, and you know what is S11, S12, S21 and S22. Alright, so now with help of these parameters I can write my reflected wave is equal to my scattering factor into my incoming wave or incident wave. Okay, so I can write like B is equal to my scattering matrix into A, right? So for a two port network, so I have B1 as my reflected wave, B2 as my reflected wave, that is my output, is equal to, what is my scattering parameters? S11, S12, S21, S22. What is my incident wave? That is A1 and A2. So I can write like this. Okay, so from here I can derive the equation by multiplying this matrix. So B1 is equal to S11 into A1 plus S12 into A2 plus S12 into A2. Same way I can write for B2 is equal to S21 into A1 plus S22 into A2. So S21 into A1 plus S22 into A2. So this is my final equation. So likewise I can go for 3-port network, 4-port network, for multi-port network. Yes. So for 3-port network, what will be my number of parameters? So for n is equal to 3, I will have 9 parameters. So what is that? S11, S12, S21, S13, S21, S22, S23, S31, S32, S33. So this is for your 3-port network matrix. Likewise we can go for multi-port network. We can write equation for multi-port networks, right? So we'll stop with this. Next session we will discuss about S parameters for every components.